A lot of movie science is wrong on purpose, and that is exactly why it can teach. A thrilling mistake, shared by millions, can become the perfect doorway into reality. Science fiction on screen lives a double life. One life is myth, pure wonder. Astronauts cross impossible distances. Machines wake up and demand personhood. Dinosaurs return. Time bends into a road you can drive. The other life is quieter, but more interesting. Every sci-fi film also makes an argument about how the world works. It asks you to accept a model. Maybe gravity can be controlled. Maybe a signal can cross a galaxy. Maybe a mind can be copied. Maybe biology can be hacked, like software. Sometimes that model is careful. Sometimes it is poetic nonsense. Often it is both in the very same movie. Auditing the science is not about killing wonder. It is about noticing what the story asked you to believe. Movies are not lab reports. They have budgets, symbols, and deadlines. They also have an obligation to keep moving. A director may use visible laser beams so the audience can track a threat. A sound designer may put noise into space combat because silence feels flat. A screenwriter may compress years of travel into days because real timelines can smother drama. Those choices are not automatically sins. Cinema is the art of selection. Still, the best science fiction becomes part of our public imagination. It shapes what people picture when they hear black hole, AI, Mars habitat, alien language, or genetic engineering. For many people, the first contact with a scientific idea is not a class. It is an image. A rotating space station, a dinosaur eye behind glass, an astronaut tumbling above Earth, a calm computer voice that refuses to be shut down. That is why the accuracy question matters. Not because every spaceship must obey a textbook, because every violation or shortcut teaches something anyway. Sometimes it teaches the wrong thing. Sometimes the correction is what sticks. There is a fear that scientific criticism drains the magic. Nobody wants a beloved film reduced to nitpicks. Nobody wants the person whispering "actually" through every scene. Yet wonder and accuracy are not enemies. In fact, constraint often makes a scene stronger. Vacuum is scarier when you understand pressure. Interstellar distance feels lonelier when you grasp what a light year implies. Evolution becomes more beautiful when you see selection and trade-offs, not just cool creature designs. Real science does not shrink imagination, it gives it texture. Think about a film that respects silence in space, or shows the slow rhythm of procedures. Those choices make the world feel heavier, and therefore more real. A good audit is not a police report. It is a second viewing. The first viewing asks, "Did the story move me?" The second asks, "What model of the universe did I just accept?" Here is where the fun begins. Bad science in cinema can be irritating, but it can also be productive. A vivid misconception is easier to teach from than a vague feeling. Take the classic example of loud spacecraft in vacuum. The mistake is basic. Sound needs a medium. Space has no air to carry it. Yet the correction becomes memorable precisely because the wrong version was thrilling. Or take the idea of reviving dinosaurs from ancient DNA. The premise stretches molecular biology past its breaking point. DNA degrades. You do not get a complete genome, neatly preserved, waiting to be read like a barcode. But that very impossibility opens a rich set of real questions. What survives over time, and what does not? What genome reconstruction would require? Why cloning is not just having the code. Development also matters because an organism is built through timing, regulation, and environment, not printed from a strand of DNA. Even the silliest premise can point to a real discussion. Turning humans into batteries fails basic energy accounting. Yet it still leads people toward questions about virtual reality, neural interfaces, and the psychology of presence. The literal mechanism collapses, while the intuition about mediated experience remains powerful. In education, this is gold. A whole room has seen the same image. The class shares the same wrong answer. That shared reference can make the real principle easier to land. So what does scientific realism mean in this approach? It doesn't mean a movie is only good if it is accurate. That would be a dull way to watch films and an unfair stand-in for art. Scientific realism here means something more precise. How honestly and how coherently a film treats the scientific assumptions it depends on. A movie can be unrealistic in detail, but realistic in spirit. Sometimes you can feel that spirit in the attitude of the story. Does the protagonist survive because the universe bends for them? Or because they keep solving constrained problems, with mass, energy, chemistry, time, and human error always pressing in? By contrast, some films borrow scientific vocabulary as decoration. Words like quantum, genetic, AI, dimension, radiation, evolution, frequency, nanotech, and entropy often get used like incantations. The plot needs a door opened, so a science-sounding phrase becomes the key. Realism is not the same as literalism. No film can show every calculation, calibration, and failure review. Realism is a pattern of respect. Does the film know when it is simplifying? Does it preserve the constraints that actually matter? Does it recognize the difference between an unknown and an impossibility? A useful way to think about movie science is as 4 categories. First, there is accurate science. It may be compressed, but it does not fundamentally mislead. You might see believable weightlessness, pressure loss, signal delay, or contamination protocols. Compression is the key word. A scene does not need to become a lecture to be accurate. Sometimes a silent exterior shot teaches vacuum better than dialogue ever could. Sometimes a delayed reply teaches distance more effectively than a star map. Second, there is plausible extrapolation. The technology may not exist, but the film respects what would be required. Energy, materials, control systems, failure modes, scaling up, maintenance, social adoption. The best speculative films do not just say advanced, they imply the hard work underneath. They make you feel that future breakthroughs would still be specific and engineered, not magical. Third, there is useful fiction. These are premises that are impossible or extremely unlikely, but still valuable as thought experiments. Faster than light travel, time loops, human-level androids, translation miracles. Used well, these ideas become philosophical machines. They let a film ask about identity, mortality, power, and personhood. The science may fail as prediction, while the story succeeds as inquiry. These are claims that collapse under gentle scrutiny and do not offer much payoff beyond spectacle. Entropy reverses because the plot demands inversion. A creature gains enormous mass without energy input. A mutation gives whatever ability the next scene requires. Naming that category is not moral condemnation. It is clarity. Some stories want to be myth. The problem is when a film claims scientific seriousness while running on pure spellcasting. To keep the audit fair, not all mistakes are treated equally. Movies routinely compress time, simplify interfaces, and skip checklists. Those are often acceptable shortcuts. You do not need a 10-minute airlock procedure in every space film. The more serious issue is when the central mechanism depends on a falsehood so large that the world loses credibility. An inaccurate star field is minor. Banking turns in vacuum may be conventional visual language, but crossing interstellar distances with no energy source, no time cost, and no consequence, that is a premise-level break. The same logic applies in biology. Alien life can be strange, and it should be. But a life cycle that adds mass without food, or a pathogen that rewrites whole bodies instantly, ignores what makes biology biology. It ignores development, metabolism, and constraint. A fair audit also gives credit. Otherwise, criticism becomes tedious. Many films get more right than their reputation suggests. Some preserve one crucial principle, even while bending others. Some show the texture of scientific work, even if the final answer is wrong. That texture matters. Instruments, uncertainty, experts disagreeing under pressure, tools breaking at the worst moment, the loneliness of spaceflight, the bureaucracy of research. These details teach audiences that science is a practice, not a sequence of revelations from lone geniuses. One of the most important distinctions is between a conceit and a mistake. A conceit is the what-if that gives the story permission to exist. Without time travel, there is no time travel story. Without an alien signal, there is no contact story. Without a simulated world, there is no simulation story. A mistake is different. It is an unnecessary violation inside the room after the premise has opened the door. Strong films often establish one impossible doorway, then behave carefully once we step through. Weaker films keep adding new doorways whenever the plot gets trapped. To make that carefulness visible, the audit looks across 4 domains: Physics, biology, engineering, and plausibility of the premise. They overlap, but each highlights a different kind of constraint. Physics covers motion, energy, gravity, thermodynamics, radiation, pressure, sound, relativity, and scale. Space films often live or die here because orbital mechanics is unintuitive. Partial understanding can be more misleading than ignorance, especially with big concepts like time dilation. Biology treats life as a system: evolution, metabolism, reproduction, ecology, development, disease, aging, and embodied cognition. Real organisms are not designs. They are histories shaped by trade-offs, environments, and ancestry. Engineering asks how you turn a scientific possibility into a working system: materials, redundancy, repair, safety margins, interfaces, operations, and failure modes. A thing can be physically possible and still engineering impossible in context. Plausibility of the premise asks how much the central what-if demands. Some premises are modest extrapolations. Some are radical but coherent. Some are impossible in ways that are useful. Some are impossible in ways that are careless. Many errors come from cinematic pressure, not ignorance. Space is silent, but movies like sound. Communication is delayed, but movies like conversation. Evolution is slow, but movies like sudden transformation. Research is collaborative, but movies like lone geniuses. Cameras also have preferences. They like visible causes and immediate effects. They like faces, countdowns, and button presses at the last second. Scientific reality is often delayed, distributed, statistical, or too large to fit neatly in a frame. Because of that, filmmakers translate science into older cinematic languages. Starship bridges become submarine decks, labs become wizard chambers, AIs become people in boxes, genetics becomes mixing traits, because it is easier to show than regulation and development. Metaphor adds another layer. Some of the most scientifically questionable moments are also the most powerful images. An impossible object can stand in for incomprehensible intelligence. A biologically extravagant monster can condense fears about violation, reproduction, and exploitation. A tortured physics idea can still turn causality into choreography. An audit should not be blind to metaphor. The question is whether the metaphor required the misrepresentation or whether better science could have strengthened it. Often, reality is not less dramatic than fantasy. It is just less convenient. In the end, science fiction asks, what if? Science asks, under what conditions? Living in the charged space between those questions changes how you watch. The movie may be wrong, but the question it raises can still be magnificent.